right, so I'm here working on some MacLaurin series, and I've got a question about a pretty nasty looking function. And the question is, how could we maybe approach this in a little bit more of an elegant way? So the natural log of 1 plus sine x. And I'm asked to figure out what the MacLaurin series is for that up through the fourth degree. And so what I'm actually going to use is I'm going to use a couple different formula that are given to us. The natural log of 1 plus x is given to us as just, it's sort of this alternating pattern, etc. And I actually don't need to go past that because I'm only going to go up to the fourth order. So remember, throughout this process, I'm only trying to get up to the power of 4. And I'm going to use sine of x, which is x minus x cubed over 3 factorial plus, and I'm not going to go to the next term because the next term would be x to the fifth. And again, my goal is only to get up to x to the fourth. So my claim is that if we know natural log of 1 plus x results in this expansion, then we know that the natural log of 1 plus sine of x has to result in this expansion. X in the x down here is going to be replaced with sine of x minus, again, x right here, sine of x squared, and then sine of x cubed over 3, and then sine of x to the fourth power over 4. And what I'm going to do is then use this version of sine of x to substitute in right there, 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 and there. And this can get really nasty, but we're going to be very careful about what terms we actually calculate. Remember, again, our goal is to get up to the fourth degree. In theory, you really have an infinite number of terms being squared and everything. But in practice, you only care about the first couple terms because remember that a MacLaurin series is an approximation, and the approximation can get as good as you want. It can get arbitrarily good. The first several terms take care of most of the approximation. So I'm only going to sub in the first two terms of sine of x in practice. So then I have the first two terms of sine squared over 2. The first two terms sine cubed, there we go, over 3, and the first two terms of sine to the fourth power over 4. And I'm even going to skip a little bit of steps as I try to square this out. Like, for example, I distribute it all out. For example, I don't need to do x to the third squared. I don't need to do x to the third cubed. I don't need to do x to the third to the fourth power. So really, all I need to calculate out, the first two terms are going to survive because they're smaller than the fourth power. For the second term, all I need to do is x squared, and then I also need to do x times x cubed and x cubed times x. There's two of those, it's like a squared, 2ab, b squared. So I have minus 2 copies of x to the fourth over 3 factorial. Let's just switch it to a 6 at this point. Okay, now same idea here. I actually only have x to the third surviving on this term. And the reason I only have x to the third surviving is because if I multiply x times x to the third once, I get x to the fourth. But there's 3 total factors, so I would need to multiply it by another power of x. So the only way I can get something that is less than or equal to the fourth degree is if it is only the x term that is raised to the power. And the exact same logic applies here for x to the fourth over 4. After that, it's just fun with fractions at this point. So I have x minus x cubed over 6 minus x squared over 2, double minus x to the fourth, I guess, over 6, plus x to the third over 3 minus x to the fourth over 4. So now we're just going to do common denominators. So this is 2x to the third over 6. This we can make out of 12. This we can make out of 12. And so altogether, in order, we have x to the first. What was my x squared? X squared was over 2. What's my x cubed? X cubed is a positive x cubed over 6. Then a negative x to the fourth over 12. Okay, so there we go. Now, this question asks us to really try to use that information that we just figured out on some other variations of the MacLaurin series. So what I'm going to do is I'm going to erase some of this working here and see how we can use the result that we just got, hopefully. That's what the questions are constructed here, to make you use your previous results. So you don't have to start from scratch every time. If you start from scratch every time, it's just way too hard or way too time consuming. Maybe not necessarily hard. I wish my eraser worked better. Okay. We're going to be okay. Great. Okay. So I'll switch colors so hopefully you can see a little clearer. So the next question that I'm asked about is, okay, so we know that natural log of 1 plus sine x is that expression down at the bottom. Could we figure out the MacLaurin series for the natural log of 1 minus sine x? Well, that's just replacing all of the positive sine x's with negative sine x's. And so that means I can just replace all of the positive x's with negative x's. So negative x. Oh, it's being so laggy. So I'm sorry if the quality is getting worse for you. Negative x squared over 2. Positive or plus a negative x cubed over 6. And then minus a negative x to the fourth over 12. And so then just doing your positives and negatives, you get negative x squared over 2. I guess that's going to be a negative, so I can write plus negative, x cubed over 6, and then just a single negative x to the fourth over 12. Okay, so there's that. Then, bizarrely enough, it asks you about the natural log of cosine x. So this one's a tricky one. If you look at the natural log of cosine x, how am I supposed to use the answers that I already have? Well, I have a 1 plus sine x and a 1 minus sine x. And I know that 1 minus sine squared x is cosine squared x. So I know also with logarithms that if I have a power on the inside, then I can make that a multiplication on the outside. So here is one way you could construct this. I hope you would agree that 1/2 times 2 is equal to 1. Like that. Natural log cosine x. And so then I hope you would agree that the power in front, I'm going to bring the 2 in front to make it cosine squared x. And then I hope you would agree that I can write that as the natural log of 1 minus sine squared x. Okay, well, if that's the case, I also hope you would agree that I can write that as 1/2 times the natural log of 1 minus sine x times 1 plus sine x. Because that is a like difference of two squares. And then I hope you would agree that that's 1/2 times, if you have multiplication inside of one log, that means you have addition between two separate logs. So check that out. And the great thing is we just took the problem and reduced it to a sum of the two MacLaurin series that we already figured out. And what I'm noticing on the MacLaurin series is that all the odd powered terms are going to cancel out. All the odd powered terms are going to cancel out. And so that leaves us with just what's left over. Let's see. So all the odd powered terms cancel out, and so that leaves me with two copies of the even terms. So 2 times the even terms. Negative x squared over 2, negative x to the fourth over 12. And we're still only going up to the fourth power, and so the 1/2 and the 2 cancel out. And so I have a wonderful answer for the natural log of cosine x. Then it asks me to figure out the natural log of tangent of x, and you can do that, or not the natural log, just the tangent of x, and you can do that in a similar way by trying to consider different combinations of sine and cosine. This video is getting too long, so I'm just going to leave it there. If you have specific questions, just let me know, and I'm happy to do it in a separate video. Thank you for watching.